Hello Year 11, this is Mr Walkerdine. This is the day before your second science exam, which, as you should know, is Chemistry Paper 1. I want to provide you with some reassurance and pieces of information and advice on how best to prepare for this particular examination. On Chemistry Paper 1, there is a range of knowledge content that you must know. These are C1 atomic structure, C2 bonding, C3 quantitative chemistry, C4 chemical changes, C5 energy changes. Aligned with the knowledge content, there are 3 required practicals that you must know. These are making salts, electrolysis and temperature changes. All of these required practicals you will have undertaken during a lesson or series of lessons during your 3-year period of study in science. In the exam, the examiners will ask you to look at one or more of these required practicals, where they will either ask you to describe a method, apply your knowledge to a different context, plot data into a graph, and finally they may ask you to evaluate and identify improvements for a specific method. You will find the key details for these required practicals on a set of links on class charts, or you will be able to review these in your knowledge organisers that you have. It is always tempting the night before an exam to cram, to watch videos of the required practicals or of the content, to reread your notes, to do another exam paper. Please, don't do it. What you need to be is well rested and alert to tackle the questions on the paper on that day. Therefore, there are 6 tried and tested simple rules for you to apply the night before your exam. Number 1, as I've suggested, do not pull an all-nighter. Make sure that you get enough sleep. 2, avoid caffeine the night before. 3, if you can, the night before, get in a quick workout. So about half an hour of exercise or taking your dog for a walk. Ensure that the night before that you take frequent breaks from your desk. 5, make sure that you stay hydrated. 6, ensure that you eat a breakfast that enables you to stay focused for the length of the examination, which is 1 hour 15 minutes. The exam board has kindly provided a range of key ideas in chemistry. There are more key ideas than this, but these are the key ideas that are going to be looked at in this particular presentation. The first key idea is matter is composed of tiny particles called atoms, and there are about 100 different naturally occurring types of atoms called elements. All of these elements are found in the periodic table. The periodic table of elements is an insert that will be provided to you with the examination paper on Friday. When you are told to start your exam on Friday, firstly, annotate the periodic table. Split the periodic table into metals, non-metals, identify where the groups are, name the groups, specifically group 1, group 7, group 0, and identify where the periods are, that they are the rows going across the periodic table. Key idea 2 in chemistry is that elements show periodic relationships in their chemical and physical properties. These properties can be explained in terms of the atomic structure of the elements. In the slide you can see that it looks at the atomic structure and what subatomic particles make up the atom, the protons, the electrons and the neutrons. You might be in a question asked to state where they are found, what the charge and what the relative mass are of each of these subatomic particles. Secondly, there's an electronic structure which you can identify is beryllium from its structure. It's got 2 shells and it has 2 electrons in its outer shell, therefore it's in period 2, group 2, and that element is beryllium. Using the periodic table, we can identify electron shell diagrams. In this diagram, using the periodic table, we can identify that there are 4 electron shells, and therefore calcium is in period 4 of the periodic table. In the first shell, there is a maximum of 2 electrons. In the second shell, there is a maximum of 8 electrons. In the third shell, there is a maximum of 8 electrons, leaving 2 electrons in the outer shell of calcium. Calcium is found in group 2 of the periodic table. Group 1 elements are known as the alkali metals. The group 1 elements have 1 electron in their outer shell. They look to lose that outer electron to achieve a full outer shell. When they achieve the full outer shell, they have then 1 more proton than they have electrons, and therefore they have a 1+ charge. The reactivity of the group 1 elements increases as you go down the group. Group 7 elements, known as the halogens, have 7 electrons in their outer shell. These elements need to gain an electron to achieve a full outer shell. When they form ions, they gain a -1 charge. The key point with reactivity is that as you go up the group, the reactivity increases. Key idea 3 is atoms bond by either transferring electrons from one atom to another. In this example, what we can see is a sodium atom loses 1 electron to form a sodium plus ion. A chlorine atom gains 1 electron and it forms a chloride ion with a full outer shell, and there is a strong electrostatic force of attraction between those 2 ions, which is the ionic bond. Atoms can also bond by sharing electrons. In this example, hydrogen fluoride, a hydrogen shares 1 electron with fluorine to achieve a full outer shell, so it is sharing electrons to achieve a full outer shell for both atoms. In bonding, we have to be able to relate to how the bonding and structure are related to the properties of the substance. Here is shown chlorine. Chlorine is a gas at room temperature. Therefore, chlorine has a low boiling point. Chlorine is composed of small or simple molecules. Between the molecules, there are weak intermolecular forces as shown by the red lines. These weak intermolecular forces require little energy to break the forces between the molecules. Therefore, a low boiling point. The way giant structures are arranged is of great importance in terms of the way they behave. The model shown here is that of sodium chloride. Sodium chloride has a high melting point. This is because it has a giant ionic lattice structure. There are strong electrostatic attraction between the ions, which requires lots of energy to break the bonds. An example of a giant covalent structure is graphite. Graphite conducts electricity because each carbon atom has attached 3 other carbon atoms, which means that each carbon has 1 delocalized electron to carry the charge through the layered structure. Secondly, graphite has a property of being soft. This is because it has layers that can slide over one another. This is because there are weak forces, which are weak intermolecular forces between the layers. Little pressure on these layers, the layers slide over one another. This is quantitative chemistry. An example is shown in the slide for calculating the percentage of oxygen in calcium carbonate. There is a 3-step approach which you should take to any percentage by mass of an element in a compound. Step 1. Calculate the relative formula mass of the compound. Step 2. Calculate the mass of oxygen in the compound. You calculate this number of atoms of oxygen times by the relative atomic mass of oxygen. So in this case it's 3 times 16. You then find the mass of oxygen in the compound divided by the relative formula mass times by 100 to give you the percentage. There are 2 formulae that you require for C3 quantitative chemistry. Moles equals mass divided by relative formula mass. This is for higher tier students only. Higher tier students will need to know this, to use moles for reacting masses, to use moles for balancing equations, and for identifying limiting reactants in chemical reactions. Secondly, concentration equals mass divided by volume. When answering calculations, please ensure that you show all working out in your calculations. The examiners are looking to award you marks. If you show you're working out, you can get error carried forward marks, which is where you will gain some marks for that particular question. Key idea 4 is chemical reactions can take place via electron transfer. The reactions that are shown here are displacement reactions, and that uses the idea of the reactivity series. More reactive metals displace less reactive metals in a compound of that metal. Acid reactions can be asked in the question paper linked to the required practical making salts, or as a full question or part of a question on its own. You will need to use the chemical equations that are shown. Metal plus acid gives us salt plus hydrogen. Metal carbonate plus acid gives us salt plus water plus carbon dioxide. Alkali plus acid gives us salt plus water. You will need to know that in an alkali it has hydroxide or OH minus ions, and an acid contains hydrogen or H plus ions. In electrolysis, an ionic compound is melted so the ions are free to move within the liquid. These liquids conduct electricity. When you pass an electric current through the electrolyte, which in this case is the copper chloride, it causes the ions to move to the electrodes. The negatively charged ion is attracted to the positively charged anode. The positively charged ion is attracted to the negatively charged electrode, the cathode. In this, you can see that the copper 2 plus ions are attracted to the cathode, and the chloride ions, Cr minus, are attracted to the anode. Key idea 5. Energy is conserved in chemical reactions, so it cannot be created or destroyed. This links in with exothermic and endothermic reactions. Shown on the slide are the reaction profiles for exothermic and endothermic reactions. You may be asked to identify the reaction profile, label the reaction profile, draw the reaction profile. You will be asked to link exothermic and endothermic reactions to a specific required practical on temperature changes. And finally, for those of you on the higher tier exam, you'll be asked to calculate the energy transferred in chemical reactions using bond energies. In any questions on required practicals or analysing a particular experiment, don't use the word amount of metal, amount of acid, amount of proton and electron. Instead, use the mass of each metal, the number of moles, the volume of acid, the concentration of acid, the number of protons. By doing the latter, this ensures you achieve 4 marks on that question. On the chemistry paper, you can see that there will be at least 20% of the paper which will be on calculations. It's more likely that for the foundation paper it's more like 25%, and for the higher tier paper 40%. Therefore, you will need your scientific calculators. Mr. Walker and I's predictions are questions on structure of the atom and isotopes, periodic table, specifically looking at group 7 reactivity and displacement reactions, identifying that noble gases have full outer shells and therefore are inert, linked to C2, electronic structure linked to bonding, showing ionic or covalent, identifying how the structure affects the properties of graphite and diamond, conservation of mass calculations, percentage by mass calculations, and reacting masses. For required practicals, I think there will be a making salts question. Possibly this could be a neutralization reaction, or it could be a reaction using an insoluble metal oxide, reactivity of metals, electrolysis and extraction of aluminium. And then for C5, the temperature change required practical, reaction profiles and calculations of overall energy change. 40% of each paper will be asking you to apply what you know to a new context or new scenario. Many candidates find the first part of the question difficult. This is often due to an unfamiliar context or scenario. If you see something unfamiliar, don't panic. Read the question. Highlight the key words in the question, as it will help to make clear what the question is about. Pre-planning the night before the exam, the equipment that you have in your bag will reduce stress and anxiety. Make sure that you have 2 black pens, a pencil or pencils, a ruler and a calculator. To all of you in Year 11, I wish you the best of luck in this Chemistry Paper 1 exam.